YouTube channel. In this video, I am going to explain you about one of the important topic from CSIR-UGC NET, that is probability and permutation and combinations. So in the previous video, I have discussed with you about calendar clock problems, numbers, series and formation. So please go to those videos. So let us discuss about the probability first. Probability is the branch of mathematics concerning event and numerical description of how likely they are going to occur. So probability is the related to what occurring an event and numerical description of how it is going to occur. It is a number that lies between 0 and 1. So probability equation is given by number of outcomes to the total number of outcomes. So what is random experiment? That is, if it doesn't give the same result for any of the occurrence of event, then it is called random experiment. If you toss a coin, you may get head or tail. Okay, we don't know the it may not give the same result for the occurrence of event. So event is what? A collection of one or more outcomes of the random experiment. So when you throw a dice, you may get it has 6 faces. You may get 1, 2, 3 up to 6 values. So mutually exclusive event. So occurrence of one event exclude other event. So if we take a coin, it has head and tail. If head occurs, tail is going to be removed. So like that. Union of event. Let A and B be two events in a sample space. If we can denote it by A union of B, the symbol for union event. So collection of all outcomes will give union event. Intersection of event means collection of all elements only belonging to A and B. So if the common elements are there in A and B, we can write in terms of symbol A intersection of B. So sample space or outcome space, set of all possible outcomes is called sample space. We call whatever the outcomes we get, that as sample space. So let us take some example here. Random experiment, rolling a dice. So the sample space is what? Possible, all possible outcomes. So here all possible outcomes for rolling a dice is how many? 6. 1, 2, 3, 4, 5, 6. So football game, if we take, so all possible outcomes will be win or loss or draw. So this is the sample space for this game. Toss a coin. So if we toss a coin, we can get head or tail. This is the sample space for this random experiment. If we take two coins, that means we should have the combination of head and tail, tail head, head head, or tail and tail. So that is the sample space for two coins. So example, rolling a dice, event A as the occurrence of an even numbers. If we roll a dice, sample space is given by 1 to 6. That is total outcomes will be 6. And even number they are telling. So here in this sample space 2, 4, 6 are what? Even numbers. So then number of outcomes even number is 3. So probability is what? Number of successful outcome to the number of possible outcome. So successful outcome will be 3. Total outcomes will be 6. So 3 by 6 how much? 1 by 2. So this is the probability of occurrence of an even numbers. Similarly, we can calculate odd numbers. Important points. So probability of an event ranges from 0 to 1. Means it is always lies between 0 to 1. It is less than 1 and greater than 0. So sum of probabilities of all events in sample space is equal to 1. So if we add this sum of all the events probabilities, then it is equal to 1. It should not be greater than 1. So for two events A and B, the union of the probability is given by this equation: P of A, P of B minus P of A intersection of B. So two exclusive events is given by P probability as a function of A intersection of B is equal to P of A plus P of B. So these important points you should remember. So next we can go for permutation and combination. So before that you must know factorial notation. So let us consider n as positive integer denoted as the factorial n. This is the symbol to write the factorial. So if we take n as positive integers, so we can write the formula as n into n minus 1, n minus 2 up to 3 to 1. And the value of 0 factorial is always equal to 1. Let us take example 7 factorial. How we can write it? That is 6 into 5 into 4 into 3 into 2 into 1. So like that we should write. So permutation is an here you should multiply with 7 also. 7 into 6 into 5. Okay. Permutation is an arrangement of all or part of a set of objects with regard to the order of the arrangement. So here order of the arrangement is very important. So here one example, suppose we have a set of 3 letters A, B, C. Consider the different ways by which we can arrange 2 letters from that set. Each possible arrangement would be an example of a permutation. So the complete list of possible outcomes will be what? AB, BA, AC, CA, BC and CB. This is the order we can have arrangement of the objects. So here the definition is permutation is an arrangement of all or part of a set of object with regard to the order of the arrangement. So all permutation made with the letters A, B, C, taking all at the time. Then we can also have the set of 3 letters A, B, C, B, C, A like that. So here the general formula for number of permutations is given by NPR is equal to n factorial divided by n minus r. Very important formula this one. So here number of all permutations, n denotes of n things and taking r at a time. So we are selecting in n things r at a time. So let us take the example 5 permutation of 3. That is here the number of permutations is 5. So we are taking 3 at a time. So here you can do the 5 factorial is how 5 into 4 into and so on. 5 minus 3 is what? 2. 2 factorial 2 into 1. So 2 this get cancelled. So 5 into 4 into 3 60. So like that you can go for this example 6 permutation of 2. Combination. So as the name indicates, a combination is a selection of all or part of a set of objects without regard to the order in which the object selected. So here order doesn't matter, but selection of the objects is important. Set of 3 letters. Let us take the 3 letters. Different ways of selecting 2 letters. So we can select A, B, B, C, C, A, or we can also select like B, A, C, B, A, C. So order doesn't matter, but selection of the selecting the objects is important. So number of combinations for n things selecting r at a time, that is given by NCR is equal to n factorial r factorial n minus r factorial. This is very important formula for combination. So in permutation only we have n factorial divided by n minus r. Here r factorial is included in combination. So let us take one example 6 combination of 3, that is equal to 6 factorial divided by 3 factorial 6n minus r, that is 6 minus 3. You can do and calculate the value. So how to identify permutation or combination? A permutation focuses on the, as I said, arrangement of objects with regard to the order. So order is very important in case of permutation. So combination, in contrast, it is opposite to the permutation, focuses on the selection of object without regard to the order. Okay, so check if order matters, permutation, otherwise combination is important. Arrangement of objects is what? Permutation. Selecting objects is what? Combination. So number of different permutation of n different things. Taking all n things at a time in the question, if they ask, then you can take the n factorial. So let us solve some previous year questions from CSIR NET exam. So the first question is, during a summer vacation of 20 friends from a hostel, each wrote a letter to each other. The total number of letters written was, so the options has been given. So there are 20 friends from hostel. In summer vacation, they are going to write letter to each other. If they write the letter to each other, how many total number of letters each person is going to write? So if you take 20 person, he can write letter to 19 letters he can write. So every person can write 19 letters. So he can't write himself. So 19 letters he can write, one person if you take. So there are 20 person into 19 letters, how many? 380 letters in total they are going to write. So whatever the 20 friends from hostel are there, they are going to write 380 letters each other. So option D is correct. Two integers are picked. Some questions may be twisted. You need to read the question carefully and then you can try to solve. Two integers are picked at random from the first 15 positive integers without replacement. What is the picked means what? Selected. So then obviously it is combination. You can use. What is the probability that the sum of two numbers is 20? Okay. So here both are involved. Combination and probability you have to calculate. So number of ways in which two integers can be selected is total. How many positive integers are there? 15. Selecting 2. 15 combination of 2. So use the formula, this one, calculate, you will get the value, that is 102. So 15 factorial divided by 2 factorial, 15 minus 2, that is 13. So 13 get cancel, remaining is 15 into 14 divided by 2, 105. So possible pair. So 15 positive integers are there, possible pair, sum must be 20. So when we add two numbers, we must get the 20, that is 5 plus 15, 6 comma 14, 7 comma 13, 8 comma 12. So among these combination we have the pairs which give value 20. So number of successful outcome, how many? 5. So probability is what? Successful outcomes to the total number of outcomes. So 5 divided by how many we have selected? 2 pairs. So 5 divided by 105, that is 1 by 21. So this is the correct answer. So option B is correct. What is the number of distinct arrangement of the letters of work UGC word CSIR so that you and I can't come together? So here we have to arrange the word. So that is related to permutation. Order we need to follow so that you and I cannot come together. So number of distinct arrangement of word UGC CSIR. how many letters are there? 7. So we should concentrate on here U and I, which cannot come together. So 2 ways of making the arrangement here: 7 factorial by 2 factorial. If we do, then we will get the value 2520. So 2 factorial indicates here in UGC CSIR word capital C has been repeated 2 times. So that's why 7 total number of letters is 7 and divided by 2 factorial. Number of distinct arrangements so that U and I come together, cannot come together, that is we can have U I or I U. So here UGC CSIR, then here we should write only GCCSI, I we should remove R, then U and I is what? One pair we are taking. So these 5 letters plus UI as the combination, that is 6, total 6. So we can write here 6 factorial divided by, you can select UI or IU. So 6 factorial, 2 factorial divided by 2 factorial. We are selecting 2 combinations. So 720 we will get. So U and I do not come together. So this is the value of U and I come together, and the total number of distinct arrangement of words we have 2520. If we subtract, we will get 1800. So U and I don't come together. So option D, this is 0. Option D is correct. Students of a school are divided into 4 groups. What is the probability that 3 friends get into the same group? So there are 4 groups. Let us take A, B, C, D. 3 students. Let us take student 1, 2, 3 numbers. Getting into group A, student 1 is 1 by 4, and getting all these 3 students is 1 by 4. For 3 students in the question, 3 students in the same group, then we have to multiply 1/4, 1 by 4, 1 by 4. So how many groups are there? 4. So all 3 in same group, if you want to calculate, we have to multiply 4 into 1 by 4 3 times. Then we will get this 4 get cancelled. So 1 by 16. So what is the probability of 3 students in same group is 1 by 16. Option C is correct. A code consists of at most 2 identical letters followed by at most 4 identical digits. The code must have at least 1 letter and 1 digit. How many distinct codes can be generated using letter A to Z and digits 1 to 9? So options has been given. 2 identical letters, if we take A and A, B and B, up to Z, they have given A to Z here. So 4 identical digits means same digits 4 times. 1 1 1 up to 9 9 9 9. So they have given 1 to 9. There are 8 different type of codes based on the number of characters on the code. So they are 1 letter with 1 digit, 1 letter with 2 digit, 1 letter with 3 digit, 1 letter with 4 digit. So 2 letters with 1 digit, 2 letters with 2 digit, 2 letters with 3 digit, 4 digit. So each of the above mentioned types have 26 into 9. So totally 26 letters and 9 digit. That means so the distinct course, this total there are 8 different types of course. 8 into 26 into 9 how much? 1872. So questions are little bit twisted and complicated. You need to carefully solve. Next question. A point is chosen at random from a circular disc shown in the figure. What is the probability that the point lies in the sector OAB? So options has been given. Area of the sector, this one AOB is given by, so circumference of the circle is what? 2 pi, that is 360 degree, 2 pi r. So area of the sector is given by x divided by, here this is the angle, x divided by 360 pi r square. Area means pi r square. Volume means pi r cube. So probability that point lie in the sector OAB. We can write the probability equation, area of OAB divided by area of the entire circle. Then substitute here area of the sector pi r square divided by 360 into x. So area of the circle is what? Pi r square. Then x divided by how much we will get? Pi r square get cancel. X divided by 360. Then we can write in terms of 2 pi, x divided by 2 pi. The option C is correct. So like that you should calculate or you should find out the probability and permutation combination. Here the question, if you see, this looks like geometry question, but it is related to probability. So I hope this